Hi, welcome back. I'm Naren, and in this video, we will check the problem 2 of Kickstart 2022 practice session 3. And we will look at problem wiggle walk and the problem description, and we will make some notes for the problem description. And you can see that we are talking about Banny, who has got a robot, and Banny will place the robot in a grid which has R number of rows from north to south and C number of columns from left to right, that is from west to east. And initially Banny will place robot in a position SR, SC, SR indicating the row number and SC indicating the column number, and the values of SR and SC are 1 index based, not 0 index based. And Banny will also give n instructions as a string with n characters to robot, where each character will be either N, S, W or E, indicating the 4 directions north, south, west, east, asking the robot to move in that direction. And for each move, the robot will move in that direction to visiting that square. As I said, west will go left side and east on the right side. North it will move up and south move down. And when it makes a move, that is one square move for each instruction, it will check whether the new square is already visited, like is it previously visited. If it has been visited, then it won't stop, it will continue moving to the next square in the same direction until it finds a square which was not visited before. So when it finds a square like that, it will stop there, then it will mark it as a visited square for its own tracking, and then it will read the next instruction. Here we can assume that the instruction list that robot will get will make sure that robot will never go outside the grid. So there won't be any corner cases where it will just cross the boundaries of the grid. So this will simplify the problem a bit. So next is the problem. Like, what is the problem? So when we give this kind of a grid and the starting position for the robot along with this instruction set, assuming the robot will traverse the grid based on these instructions and the starting position, we need to find what is the final position, the square, for the robot after it processes the n instructions for making the n moves. And what is the input? It's number of test cases. Then for each test case, it will read n, which is the number of instructions, r, the number of rows of the grid, c, the number of columns of the grid, sr and sc, the initial position of the robot with 1 index based value. And the next line will have a string of characters, which is the instruction string of n characters, where each character is one of the N, S, W, E, indicating the direction. Output is case hash the test case number colon. We will output two numbers R and C, which indicates the one index based row number and column number of the final square where the robot will be after processing the instruction string. And about the limit, you can note that R and C can have 5 into 10 power 4 numbers. So int 32 is enough for R and C. So these are the notes. Let's look at the sample. So there are 3 test cases. Let's look at the case 1, which has 5 as n, indicating there are 5 characters in the instruction string, which is EEWNS. Then we have 3 and 6 for the number of rows 3. You can see on the right side picture for the sample case 1. We have 3 rows and 6 is the number of columns. Then 2 and 3 are the initial positions, that is the second row, and the third column, which is in yellow color, is the starting position of the robot. So if you look at the instruction set starting from this yellow square, we have first instruction is E, so we will move right side, which is the east. So from 2, 3, that is second row third column, we move to 2, 4. Then the second instruction is again E, so we will again move to the right, going to 2, 5. So third instruction is W, so we have to go to the left, so we come to 2, 4, but we have already visited the square, so we will again move to the left, that is 2, 3. This also we have already visited, so we will again go towards left to 2, 2. So that was not visited before, so we stop there. The next instruction is N, so move up, so we will go to 2, 1 and stop there. So the last instruction is S, so we go down to move to 2, but this is already visited, so we will continue in the same direction to 3, 2. So this is the final position, final square of the robot. So answer is third row second column 3, 2. So case 1 answer is 3, 2. So let's look at the algorithm. So since we need to track whether a square is visited or not, we need some data structure to store that information, whether a square is visited or not. So we can use a 2-dimensional vector representing the grid and the information whether a square in the grid is visited or not. Then we also need to track the current square where the robot is at present before reading the next instruction. And then we will move one instruction at a time, and according to the instruction we will move in the grid, and we will check whether the square is visited or not, and after the visit we will also mark it as visited. So that is our algorithm. And let's look at the code template. So we will read the number of test cases T, then we will loop through each test case where we will read N, the number of instructions, then R and C for the grid size. Then we will read the starting position SR, SC, which are one indexed based values. Then we will read the instruction string I, where each character is an instruction. Since this is a template, we will initialize the final row and column of the robot with the starting position, and we will print that as the final answer. Let's look at the code for algorithm. So what is the initial state? Let's have a vector. As we discussed, we will have a two-dimensional vector of size r and c, number of rows and number of columns. Since we are using a zero index based values by accessing this vector, we are modifying the starting position to zero index value by decrementing one from each and initializing the final row and column to the updated value of the zero index based starting position. And the main loop is we will go through the instruction character and check whether it is, say, west, east, north or south. And for each case, let's say if it is E indicating east, that means we need to move towards right. So we have to increment fc++ because we need to increment the column count towards right. And once we increment, we need to check whether that square is already visited or not. So we are using value of 1 for the grid cell indicating it has already visited and 0 for not visited. So if it is already visited, we go still further in that direction until we get a square which is not visited, that is it's not equal to 1. And once we get such a square, we will set that square to visited and go back to the next instruction. Note that since the assumption in the problem is the instruction set will not allow to go beyond the boundaries of the grid, we don't have to worry whether fc hits the edge. Similarly, for W instruction west, we need to go left side. That means instead of incrementing fc, we will decrement fc. And for north and south, instead of fc, we will decrement or increment fr, that is the row. So for north going up, we will decrement the row count, and for south, we will increment the row count. If we run it locally for the initial test case that we discussed of 53623, answer should have been 3, 2, but we get 3, 3, so which is wrong answer. So what is the error in this code? You can pause the video and think. If you debug with, let's say, SCOut to print each move of the robot, what is the square it is visiting, you will notice that in the current code, the blue colored arrow marks indicate how the robot will traverse the grid, and the square, blue square, indicates the final position, which is 3, 3. So can you find out now what is the error, what is the issue with this code? The issue was we forgot to initialize the starting squares visit, because since we are starting from SR comma SC, in this case it was row 2 column 3, before making the move or before reading the first instruction, we should have set the starting position as visited. So that was not done before, so we need to do grid of FR FC to 1 before going through the instruction list. Let's try to run the problem. Running the test cases. Submitted, it's pending, and it's completed, and answers are 323337, which is correct. Let's submit the attempt. It's pending. Okay, it finished with MLE, memory limit exceeded error. So how to fix this MLE, memory limit exceeded error? When we ran this code locally, we know that this succeeded, but when we submitted, it resulted in MLE. That means there is some issue with how we are using the memory. So indirectly it's saying that we are using a lot of memory than the limit that was given to this problem. So can you pause and think what was the issue with this code? So note that we have a grid, a two-dimensional vector of size R and C, and the value of each cell in this grid is int 32. Is it really necessary? Since we just want to store whether a cell is visited or not, we just need a boolean kind of value, and we can as well use a bool as the value of this two-dimensional vector. And if you change the code accordingly with the new value type of the grid cells, which is bool, and change everywhere where you set or access this grid value, we can try again how this works. Let's try to submit the updated code. Run the test case. It's pending. It's completed, and it's 323337, which is correct. Let's submit the attempt. It's pending. Okay, it's successful. Test set 1 and 2 passed. Let's check the score. We got 6 plus 8 for wiggle walk, and total score 27 for problem 0, 1 and 2. So some tips based on this problem that we looked at. Always think about the state that you are trying to maintain as you solve the problem. Like if there are some number of iterations, you try to maintain some state. So think about that state and how it changes over the course of the iterations and how it starts. So remember whether everything is initialized to the proper values, and also remember that everything is reset or whatever the update we have done properly at the end of the iteration. And also minimize the unnecessary memory allocation, particularly when we are dealing with a large number of data values. You can check the description for links to the other problems of the practice session 3, and I will also upload as the solutions for the remaining problems in separate videos. If you find this useful, please like, subscribe and share, and thank you for watching.